Okay, so here we go. We want to make an algorithm for this, and effectively what we want to do is we want to make us a function that we can cut up. We want to start with something that we're pretty good at, so we're going to start off with a simple polynomial, and then we're going to ramp it up to something we don't know. Here's our flow chart that we were looking at, and so we're going to kind of follow this and our pseudocode, okay? So I've got this up. I went ahead and put our pseudocode into another file, and then I went ahead and made us a MATLAB area. So let's go ahead and start. So when we look at this, we say, okay, well, what are we going to do? We're going to make a bisection method. So this is just a comment, right? And this will find a solution to f of x equal to 0. Okay? And so the idea is we've got something that we don't know how to solve, and we're going to go ahead and solve it. So what we're going to put it for inputs is our left input. So, we're going to make us a function to work with just so we have a function. So let's come over to a second file, and I'm going to name it fx. So I'm going to have y equals fx evaluated at x. And we're going to choose a function that we're good at. So y equals 4 minus x squared. Y, don't do it. Because I know the solution is going to be 2. Right? Or negative 2, but we're going to choose a positive 2. Okay? So what we're going to do is we're going to go ahead and run this. It's going to yell at us saying, well, you didn't do anything, but that's okay. This is going to be our function file that we're going to have running. And over here, we're going to go ahead and set us up. So let's choose, you don't want to choose like 1 and 3. That would be no fun. Your first cut would be 2, right? The midpoint of that. So let's do something like 1 and 5. That'll give me at least a few cuts, and maybe even something weirder than that, like 1.1. And B will be 4.9. Okay, so that'll give us awkward endpoints so that it's not easy to get to. So this is going to be my right endpoint. Okay, so the other thing we need to do is set up our tolerance. So this is going to be our accuracy. So this is going to be our correct number of decimals, I guess. Okay, and then we're going to want n max, which is going to be the maximum number of iterations. We have no idea right now, so let's put 500. So this is going to be the max number of iterations. And you see how in my code I'm telling me what I'm going to be doing. Okay, so that's step 1. Oh, and we need to set I equals 1. So this will start our counter. Okay, so that'll allow us to count. Now, step 2 is going to be a while thing. So let's say while I is less than or equal to n max, do this stuff. What are we going to do? Well, the first thing here says to do this, but I'm going to jump back over to our flow chart. We need to make sure that we're valid. So let's do that. If the two things are, if you choose 2 points on the same side of the root, then you're not going to be able to find a root, right? Or if you could imagine a parabola and you've chosen outsides, then you'll have the same problem. So we either have 0 roots or too many roots. So we're going to say something like if, and now look how I named this thing, fx, so that's what I'm going to call fx at a times fx at b is greater than 0, then they're both positive or both negative. And so then we have a problem. So we're going to display like no root can be found, right? So we need to like alert that person like, hey, this doesn't work. We need to break, which means terminate the algorithm. Stop doing anything, right? So that's kind of one option. I'm going to put an end down here, and this end is going to block my while loop, okay? So now that's been done. Let's go back over to my pseudocode. Okay, so the next thing we want to do is go ahead and make our cut. So C equals B plus A, A plus B divided by 2, right? So this is our midpoint. Okay, so now because we have something above the axis, something below the axis, by the intermediate value theorem, there must be a point in between that's 0. We're going to go ahead and find a point in between that's C. And so the question is this the right answer? So if the absolute value of the y value, it's c, right? If it's 0 or less than tolerance, if it's 0, it's less than the tolerance. So we're just going to do 1. Is less than or equal to 0. No, is less than, or let's just say it's less than the tolerance. Then we need to display, okay, we found a solution at this point. So the solution is, and then I'm going to make another display which has that solution, and display the number of iterations is, and display that number. And we'd end this if. Okay? So that's this. Okay, then stop. Oh, so we need to put a stop in there, which is going to be break. And that just says stop doing this. Okay, if that's not true, then I equals I plus 1. This is going to step forward. And then what? So now the question is, do I need to reset A or reset B? So if you come back over to the flow chart, if my midpoint is on the same side as A, then I need to move A over to that new midpoint and start again. So that's exactly what we're going to do. We're going to come over here and ask, okay, if fx at A times fx at C is greater than 0, then we know that those two are on the same side. So A is C, right? Otherwise, it must be on the side with B. So B is C, okay? Now, step 7 says, hey, if we've been running a long time, we've cut this thing up, we're not getting an answer. Something's wrong. Okay, so if I equals n max, the 1 equals means I'm assigning it, but 2 equals means I'm comparing. If this number and this number are exactly the same, I need to display an error like too many iterations and no solution found, right? We need to like say something like this doesn't work. Oh, we'll have proper English. Oh, we still don't have proper English. Well, it was a nice thought. And then we break. Okay, so if we've hit that limit, we need to kick us out, and that's going to be what's going to happen here. Okay, and then this is it. At that point, we've ended. We can do fancier stuff with our bisection, but at this point, let's go ahead and run this. It looks like it worked. It gave us a solution of 2 and an iteration of 20. So now let's change our function to something crazy, like E-type function. So how about e to the x, expx should give me e to the x minus 5. Okay, I think that has a 0, and we're just going to go between 0 and 10. And I think in there we're going to get a 0, and I found it. And we can go cheat and find out if that's accurate, but I'm pretty confident. But it took 19 iterations. So what happens if I move this down to 17 iterations, right? My maximum. Now I actually, too many iterations and no solution found. I need to increase n max to get this solution. Okay. I didn't hit my 200. In fact, 200 is wildly high. I'm only at 19. Okay. So if that makes sense, try making your algorithm and try it on the problem presented in your homework. Good luck.